I want to give you a couple tools for solving trig functions. Solving equations. I said solving trig functions, which was crazy talk, right?
Solving trig functions.
So what you need to do is you need to solve equations with trig functions. Cool?
I'm not sure. Trigonometry.
Okay, so for instance, you might have sine of 2x plus 7 equals 1/2. Oh, we did that one just a minute ago. Equals 1 over the square root of 2.
Ooh,
I know that one.
that's
So 2x equals 7.
Okay, so 2x plus 7 has to equal,
Well, yes, but like, no. It's weird to put things in radian.
pi over 4.
Radians.
what did you just?
You don't have, so if this was degrees, right?
Yeah,
You'd
well-
need the little circly guy.
Okay.
In radian land, just leave it.
Okay.
But is that the only way to get a sine of 1 over the square root of 2?
No.
No. Where else could you get one?
3 pi over 4.
Yeah. So you might have 2x plus 7 is 3 pi over 4.
Yeah, and then again every coterminal.
And then again every coterminal thing. So you might have a plus 2 pi k, where k is in z. And over here a plus 2 pi k, where k is in z.
Okay, so
And it should be noted that this is what makes solving equations with trig functions messy, right? Okay, what's my next step with this?
Well, just use algebra and solve for it.
Okay, yeah, so use algebra to solve for x. So subtract 7, then divide by 2, right?
yeah.
So you got x is pi over 4 plus 2 pi k minus 7 all over 2. So that was
It's 2 pi and 1.
Algebra.
K is just two, so it's
Oh, did the 2 pi k toss you?
Yeah.
Okay, so I'm putting 2 pi k's in here because I'm saying, okay, it's either 45 degrees, right? Or it's go once around and then stop at 45 degrees.
I see.
Or it's go twice around and stop at 45. Sorry, I said go twice and then I didn't. Once, twice, and then stop at 45 degrees. Or go once backwards, stopping at 45 degrees. Basically, you just got to count for all the coterminal angles, right? So here I'm saying pi over 4, well, or maybe go around a bunch of times and then stop at pi over
So then
4.
do you always need the 2 pi k, because technically you can always go.
Yeah.
Okay.
So you always need the 2 pi k,
And
because you always need the coterminal bits.
then
And
you
you also need the other angles, because they're not inverse functions, right? They're just partials. So this is like a plus or minus.
Is there
in
ever
square
more than
root.
2? No. 'Cause
Say again?
Is there ever more than 2?
They're ever more than 2.
Like, because right there you have pi over 4 and then 2 pi over 4? And that's-
No, the trig function inverses account for at least half the unit circle, at least until I start dividing and stuff.
Okay.
So once I've divided by 2 here, this thing actually represents probably, let me rephrase that, definitely represents 2 angles in the unit circle, and this one definitely is going to represent 2 other angles in the unit circle.
Got it.
You guys call that?
And so if we just leave it like that.
Totally.
Nothing more to do.
Oh wait, except I didn't finish this, right?
K is a z.
Because I did this one.
So plus 2 pi k, right?
No, I need this guy.
Uh-oh. I was like, what that?
So either x is this stuff that I got from the pi over 4, or x is
3 pi over 4 plus 2 pi k minus 7 over
3 pi over 4 plus 2 pi k minus 7
2. All over 2.
all over 2. And k is in z for both of these.
What do you mean by z?
All integers.
Oh, it's an integer. K is an integer. So it's plus or minus a counting number or 0, right?
You know, z, there's obviously z in integer.
You guys good with this? Is that a bit confusing?
And the two pi k and the k is at z kind of throws me off. But I think
Okay, so
I get it.
yeah,
because of the
they're
context
just
stuff.
essentially you just need to remember to put them in there
You
because
don't really use it. It's just I
oh no, you do use it. So if I was looking at what this function looks like, right? So if I think about this as a function, what's this guy?
It's a horizontal
Like,
compression.
Just
seven.
this expression,
It's a
right?
sine wave that's been horizontally compressed twice. No, I'm sorry. It's a a horizontal compression of 2 and a vertical shift of 7. Did I mess the
Horizontal compression and
So horizontal compression for sure,
shift.
and shift
Left.
something, left or right,
Left or right.
right? So,
7.
for the purposes of this demonstration, I do not even care. I just care that it got compressed and moved around, right? So, it looks like a sine wave, yeah?
Okay.
Okay. And continues, right? What does this expression look like as a function? So if you thought about 1 over the square root of 2 as a function,
Or the function you sign.
That's how tall it gets.
what was this then?
Then
Yeah, it's a horizontal line at height 1 over the square root of 2.
How'd you get that?
I don't understand.
That's what constant functions look like, right? What's that? Mx plus b,
Okay.
right? Where the m part is 0. So it's a
a
line, right, that passes through the y-axis
Yeah.
at 1 over the square root of 2
Okay.
and has 0 slope.
Okay,
Gotcha.
So that's flat, right? That's like this. And then what are these guys?
Those are all
Those are all the intersections, right? And how do I know how do I know that I need those plus 2 pi k things in there?
Because the sine wave goes on forever.
Yeah, the sine wave goes on forever and it hits this blue thing a lot.
Dang,
That's pretty cool math.
You guys cool with that?
So that they're just telling you to be.
So they're-
just telling you to be aware that there's a lot
Yeah.
happening.
So
there.
the black ones, right? Like these two guys are maybe this one and that one.
Exactly.
And then plus 2 pi k would be this one and this one. And minus 2 pi k would be the two that are over here,
Yeah.
right? And plus 4 pi k would be these two. You guys all good with that?
Yeah.
So the two pi k is just a period that.
Yeah, the
shows
2 pi k is an
process.
adjustment of the period, right? It's just telling you how many periods did you go through to get there.
So you only have to worry about the 2 pi k thing when you're solving for a variable that is within the parentheses of the trigonometric function.
Yes. Yeah, if you only have constants on the inside of your trig functions, then you don't really need to worry about this periodicity, because sine of that constant is just a number, right? And then you just treat it like it's a number, because it is. Cool? So there's 2 thoughts in your book on solving these. One is this algebraic approach that I just did. The other thought would be this graphical approach, which you can do with a calculator, right?
Yes. Which will be available during the exam, correct?
Yeah, and I would make sure you know how to do both things and check them against each other,
Yes, you can get 100%.
right? It's like the easiest thing to do is to assume k is 0, right? So if you erase that part, you can plug pi over 4 minus 7 divided by 2 into your calculator.
Yeah.
And then you can also plot these two functions
Mm-hmm.
and then scroll over to the intersect on the window and read off the value.
Yeah.
And if it's different,
You're probably wrong.
then this probably got dorked up or you punched in the formula wrong.
Yeah.
If they're the same, you can go, score, next problem.
Cool.
Also, if you can't get the algebra to work, get the graph to work at least, and tell me, I got the graph to work at least, here's what the answer is about,
Mm-hmm.
right?
Yeah.
If you can't get the graph to work, at least get the algebra done.
Okay.
You guys cool with that?
Yeah.
So 2 options, 1, both, either, I don't care. Cool.